Aloha and welcome. In this video, we're going to be talking about digital signatures. So what are digital signatures? Well, a digital signature, it's a cryptographic primitive that uses a hash function and public-private keys, that key pair that we talked about before, that think asymmetric when you hear that. And it's going to use that to verify the authenticity and integrity of a digital message. So how does this happen? So what's going to happen is we've got the message sender. They're going to compute a message digest with a cryptographic hash function, and they're going to apply that signing algorithm using the sender's private key to create a digital signature for the message. And then the digital signature is going to be sent to the message receiver along with the message. So notice that the message itself isn't being encrypted. What's happening is we're taking the message, we're running a hash on it, then we're going to encrypt the hash value, then we're going to attach that to the plain text message. We're going to send that over there, and then once they receive it at the other end, they can actually calculate the digest for themselves. They're going to decrypt using the signature. They've got an algorithm to undo the digital signature. So when they decrypt that, they're going to see the message, the hash that we had calculated at the sender's end. So they're going to compare that to the one they just calculated for themselves. If they're equal, then you can verify that it was sent from who it was supposed to be sent from, and also that the message arrived unmodified. Because if it was modified, the hash wouldn't match up. It has, and also the fact that it was they applied a private key to it. A private key is really nice in that it gives two things. One, you're identifying the origin of it, but in the authenticity of it, but you're also able to give non-repudiation because they're not able to say that wasn't me, because there's only one person that has the private key. Before, when we were talking about the max and the HMAX, we said that it didn't offer non-repudiation because it's a symmetrical key so two people have that key. In this case, only one person has that private key, so you can say that it has non-repudiation because they can't say, hey, it wasn't me. They're the only ones that have that. So that's the good thing. So in your text, you'll have this section, you'll have a nice participation activity where you can see the message going through all those different stages. So do take a look at that. You're going to have some mix and match and some questions as well. We're also going to talk about digital signature algorithms. So you've got three main digital signature algorithms, and they're going to sound very familiar because we just talked about those when we were discussing public key algorithm or cryptography. So the first one is the RSA Digital Signature Algorithm. So RSA, we talked about that before. It's based on prime numbers, very large prime numbers, and the security of it's based on just the difficulty of factoring those things. We've also got something called DSA. So DSAs are, if you'll remember, we had the El Gamal public key cryptography, and that was based on the difficulty of solving discrete logarithms. So this digital signature algorithm, when you hear DSA, just think the El Gamal, the logarithm, the discrete logarithm problems. And then the last one is the ECC, the elliptical. This is actually ECDSA. So it's the elliptical curve digital signature algorithm. So you'll notice that all three of these things have digital signature algorithm DSA of some sort, right? So you've got RSA, DSA. You've got DSA just straight, which is based on El Gamal, the logarithms. Then you've got the ECDSA. And that the ECDSA, it's based on ECC. It's the elliptical curve public key cryptography, and that's the one that's based on the difficulty of finding related points on an elliptical curve. So, like MAC and HMAC, you're going to identify what type of digital signature is used by the name. So, if you have a name like ECDSA hyphen SHA-512. SHA-512 is that actual hash function that you're using. So with elliptic curve digital signature algorithm, ECDSA, that's using, let's say, secure hash algorithm 512, it's going to have the SHA-512 in it. So it'll be ESDSA hyphen SHA-512. So it's always going to have hyphen and then the algorithm that's used for the hash function. And then security services, as we talked about before, this digital signature is providing you three different things here. The first one is data integrity. We've given it a hash, we've sent the hash, and we've sent it in encrypted form. So when it's received, they can calculate it themselves because they've got the message. And so they can actually calculate and say, okay, yeah, this is what the hash should be. Then they can decrypt the hash that we sent them and say, okay, it does match. So you know it's not been modified in transit. The second thing is you know where it came from. And you know where it came from because the person sending it has the private key. You're using the public key to undo that process, that you're decrypting it so you know that where it originated from. And it also gives you non-repudiation because only one person could have encrypted that because they are the only one person that have that private key. You're using a public key to decrypt. They're using the private key to do the encryption on it. So that's how you get the non-repudiation in there as well. So that is it for this lesson. This is digital signatures. Please do go through and look over everything. The section where it's telling you the different signature algorithms, it's going to help you kind of remember your three different types from asymmetric that we covered before, which just to go over it again, it's going to be RSA, Elgamal, which is logarithms, and then ECC. So go ahead and study that and let me know if you have any questions. Aloha.